Good morning. Today we are going to go over the practice test for Chapter 7, the Part 2, which is the open response. Remember that you want to be able to work out each of the problems by yourself, and just if you get stuck, then you can come back and just check the problems that you guys need to review. Try not to just copy the information from the YouTube. Try to work it out by yourself, and then if you get stuck on a step, then just go over the problem that you need to. Let's go over problem number 1. It says, evaluate the logarithm expression. So we need to be able to evaluate it. You guys notice the base is 5. Is log base 5 of 25. I want to be able to rewrite this as the log base 5, but I want to be able to change the 125 as a 5, base 5 to what exponent is 125? Be 5 to the third power will be 125. So using one of the properties, we can cancel this, and we have a 3. That'll be equal to 3. On example number 2, or problem number 2, it says to use the log of 2, which is approximately 0.301, and they also give you the log of 3 is 0.477. We need to be able to approximate the log of 18. I'm going to do my factor tree, so that gives me 9 times 2 is 18. 2 is a prime number. Then 9 will be 3 and 3. They both are prime numbers. I'm going to replace the 18 with the factors of 18. So I'm going to rewrite the log. Instead of 18, I'm going to replace it with 2 times 3 times 3. 2 times 3 times 3. 2 times 3 is 6, times 3 is 18. Now, I'm going to use the property of logs to be able to expand it. I have 1, 2, 3 components. Therefore, I'm going to have 3 logs. Log of 2, log of 3, and the last one will be log of 3. So I have 1, 2, 3 logs because I have 3 components. They're multiplying them all. That means that I'm going to have to add them. Now I'm going to go and replace the values. So log of 2 is 0.301. Log of 3 is 0.477. And log of 3 is also 0.477. You go and add them. 7, 7, and 1. 7, 7, 14, and 1 is 15. Carry 1. 7, 14, 15, 16, 17, 18. Carry 1. 8, 11, and 1 is 12. So I'll be approximately 1.285. Let's continue with example number 3, problem number 3. I want to be able to expand it. I have 1 log, and I want to be able to expand it to different logs. We need to be able to find out how many components we have. We have the 9, the x, the y, and the z. We have 4 components, so therefore we need to have 4 logs. All of them will be with base 9. That'll be log base 9 of 9, log base 9, log base 9, and the last one will be log base 9. So the first one was with the 9, the next one will be with the x to the 5th, the next one will be with the y, and the last one will be with the z to the 3rd power. Now the 9 and the x and the y are multiplying, so they'll be with a plus in between. The z is on the denominator, so they'll be with a minus. Now the last thing that you need to be able to do, you want to be able to use your power property to be able to place your exponent as a coefficient. We also need to be able to simplify this. If you guys notice, this cancels out, and we have the exponent left of 1. Don't forget that there's a little 1 in there. So that becomes 1 plus 5, it becomes the coefficient, plus minus the 3 becomes the coefficient. And that'll be our end result. On problem number 4, we need to be able to condense it. We have 2 logs. We need to be able to condense it into 1 log. First thing, we're going to do the opposite from what we did before. We want to be able to place our coefficients as exponents. So we'll have log base 8 of x to the 5th power plus log base 8 of y. Now I can go ahead and combine them into 1 log. Because they are adding, we are going to be multiplying the x to the 5th and the y. And that'll be our final answer. Remember, when you condense, you want to be able to end up with only 1 log. Some of you guys are writing 2 logs as part of your answer. There should only be 1 log because you're condensing from 2 logs into 1. Example number 5. We want to be able to solve the equation. So let me go and draw the line. I want to be able to leave the log base 4 of x by itself. So before I can actually get rid of the log. So first thing, I want to be able to move my 3 to the right, becomes a negative 3. That'll give me 4 log base 4 of x is equal to 12. Many of you guys are tempted to cancel the 4 in the log base 4. You can't. We want to be able to leave this by itself. Now if the 4 was on the front, just look at example number 3, you can. But if it's on the left as a coefficient, you cannot cancel the 4 in the log base 4. So in order to get rid of the 4, I want to be able to divide by 4. So now we have the log base 4 of x is equal to 3. Now I can get rid of the log. I can exponentiate both sides. The opposite of a log is a base. So I'm going to exponentiate both sides to base 4. Therefore I have x is equal to 4 to the 3rd power. That 3 becomes an exponent. That's what we call exponentiate because this becomes an exponent. Now 4 to the 3rd is 4 times 4 times 4. 4 times 4 is 16 times 4 is 64. And that'll be your answer. X is equal to 64. Problem number 6. We want to be able to solve for x. We're going to go through the same process as example number 5. We're going to draw the line. I want to be able to isolate the log on the left. So I'm going to move my 20 to the right, becomes a positive 20. That'll be the natural log of 5x is equal to negative 15 plus 20 is positive 5. We cannot divide by the 5 because we're taking the log of 5x. We want to get rid of the log first. So the opposite of a log is a base. The base for this log is e, so we're going to do a big E. We're going to exponentiate with base e. That cancels. So 5x is equal to e to the 5th power. Now I can get rid of the 5. I can divide by 5 on both sides. So my answer is x is equal to e is 2.7. 2.7 times 2.7 times 2.7 times 2.7 times 2.7, then divide by 5. Or we can just leave it as e to the 5th divided by 5. If you have a calculator, then we can just type that in and give us a approximation. Let's continue with example number 7. Example number 7, I want to be able to solve. Go through the same process, draw the line. I'm going to move my 7 to the right, becomes a negative 7. That'll be 6 for x is equal to 6. I want to get rid of the base. So the opposite of a base is a log. So I'm going to do log base 6 on both sides. This cancels. Now I have 4x is equal to. This cancels as well. So we're just left with the exponent of 1. Remember the exponent, there's no exponent for the 6, automatically has a 1. So when you cancel the log base 6 of 6, we are left with the exponent. Now we can divide by 4. That will cancel. X is equal to 1 over 4. That will be my solution. Let's continue with problem number 8. We want to be able to solve same type of problem. I'm going to go and draw the line. I want to leave the e to the 3x by itself. Therefore, I'm going to move my 4 to the right, becomes a positive 4. Now I have e to the 3x is equal to 2. I want to get rid of a base. I want to get rid of the base, so the opposite of a base is a log. So I'm going to do log base e on the left, log base e on the right. That will cancel. So we have 3x. Now remember, we don't write down log base e. We write down ln of 2. The 2 is not an exponent. Some of you guys are giving me a little 2 on top. It's the natural log of 2. Should be a big 2. Now the last step is to be able to leave the x by itself. So we're going to divide by 3 on both sides. That will cancel. So x is equal to the natural log of 2 divided by 3. Let's continue with problem number 9. I want to be able to solve the equation. I have a log on the left hand side and I have a natural log on the right hand side. The opposite of a log, I want to get rid of it. So I'm going to do a base. I'm going to exponentiate it to base e, because the log of this log has a base of e. So I'm going to exponentiate both sides to base e. That will cancel. And that cancels on the right hand side as well. I have negative 5x plus 3 equal to 3x plus 3. I'm going to go ahead and move my numbers to the right, my x's to the left. So it becomes a negative 3x, this becomes a negative 3. That'll give me a negative 8x equal to 0. I want to be able to leave the x by itself, so I'm going to divide by negative 8. Therefore, x is equal to 0. Now remember that every time you have a log on your equations, even on problem number 5, you want to be able to say, okay, if I plug in a 0 in here, well, that will have to be positive. Because remember, you cannot take a log of a negative number or 0. So if I plug in a 0, that'll be negative 5 times 0 is 0, plus 3 is 3. That's fine. If you plug it on over here, 3 times 0 is 0, plus 3 is 3. So your answer is correct. But you always want to be able to do a mental check to confirm that it's correct.